Hello, everyone. Welcome back to a new episode of Advent of Code. I don't know. I still don't really have a great title for this. Advent of Code is a great title for the series, but it's a weird thing to say at the beginning of the intro video. So I don't know. That's what I'm saying. Welcome back to Advent of Code. We're still working on part 1 of day 8. Yeah, day 8. I've been super busy. I think day... What? Well, I know what day it is today, right? 9. Yes, it is December 9th, so day 9 is already out. But I just have not had a lot of time to do anything. Hopefully, I can finish at least day 8 tonight. Maybe I can record day 9 as well. But who knows? They're taking a while. It took me a while to be able to write like 3 lines of regex parsing, but just a lot of pitfalls I didn't know I had to discover. But okay, so now that we've got this stuff, we've got a parser. Okay, so one thing is we have this print parse of whatever, right? And so we were able to run like Python this, and it just like doesn't print. Somebody pointed out to me there's this function called vars, which you can give an object, and it prints a dictionary representation of the object. Now, I expected that what I did just now to result in printing a bunch of dictionary representations of objects. Why didn't that happen? There's a bunch of stuff here. So we wrote this, and I can write like print vars of red and like return red. Like that's a... Oops. Nothing happens. Why? What? We had this problem last time that like I was running my program and I couldn't get it to produce any output, and I didn't really figure out why. I tried instead running stuff from the REPL. I don't know what the deal is with that. So I can print line, like does that doesn't even print. It's just bizarre to me. Am I missing like some crucial thing? Am I in the wrong, like... Yeah, I'm in the right directory. Print start. Like, I don't get it. It doesn't even print that. What? I'm not redirecting my output or anything silly like that. Okay, good. You guys have been looking at this screen. I forgot what screen I started looking at. Okay, very good. I was all like, oh my god, I'm going to have to throw away this whole thing because I've got everyone looking at my Chrome window instead. But good news, you didn't. So Python REPL load file. Like, can I try running this from exec file? There's a thing called exec file. Is that right? Yes. So let's try Python exec file of... Oh, but I'm not going to be able to redirect standard in, am I? Well, all right, let's try it anyway. Of source.py. And if I now were to run parse table, like that's a thing. So the file loads fine, but of course the main doesn't run, and standard in is pointing to the wrong thing anyway, so if it did run, it wouldn't get any useful input. So why? All right, let's try this. Comment all that out. Still prints nothing. Very, very confused about what could be happening here. Okay, it's not anything weird with my terminal. I'll try to reset just in case. Okay, let's comment out all of this. still nothing. Oh my gosh, I bet I have main wrong somehow. I bet that I typed this in instead of copying it from somewhere, and I typed it in wrong. Let's go look at what this, yes, it's not main, it's main with quotes. Oh, very sad. All right, well, at least we figured out the mystery. And now if I do this, everything prints exactly as I would have expected. Okay, fine. So this, by the way, this pattern here of it's already come up a couple of times in my videos for this series, which is that like I have a value that I want to use here, this. I want to say return it or store it or use it as a function argument or whatever, some expression. But like something's going wrong, and so I also want to print it, right? Seems plausible. And there's like as I understand it, in Ruby, which I don't really write a lot of, you could write something like, assuming this were valid Ruby code, which it's probably not, you could write return this dot tap of print or something like that, saying use this value here and also call the function print on it before using it. In Clojure, if I had something like this, I could write due to, and again, of course, this would be completely invalid Clojure code here, but let's assume it was. I could say due to this print line. Well, actually, I would probably put parens around it, but you don't have to. Meaning, here's the value, do some things to it, and so you can do, in fact, more than print line. You can do multiple things like save to DB or whatever. But the idea is, here's a value that I want to execute some stuff on for side effects, and then return the thing. And maybe there's a Python idiom for this, and I just don't know what it is, but it's certainly something that I'm missing. Even though it is like, doing this, even if I had the idiom for it, like sticking print line debugging everywhere is kind of primitive, and I wish I had had something better. But as it is, I have an even worse version of print line debugging because I don't know how to like do side effects on a thing. So, all right, here we go. We have a great representation of all the stuff we wanted to parse. And we can actually get to the job of doing it. Well, not quite, because we don't have a data structure for the grid. So let's start with that. Class grid. And, well, let's try, I guess, so like, I still don't quite know when in Python you want your constructor, you want to define a constructor versus just setting its fields after you create it. Like, I see constructors defined a lot, and that's like how you would do it in Java or C++, or probably C#, I guess. I don't know. But the fact that the constructors all have this like special name that you're like kind of sort of implicitly discouraged to use makes me think that it may be better Python style to not have this constructor. I don't know. Now down here, it turned out quite good that we can use the class constructor to build an instance of the class, because I didn't want to define a thing, set a field on the thing, set a field on the thing, return the thing. It's nice that there's a constructor that can do that, even though we had to write it ourselves. Jeez, how primitive. But okay, so our grid just needs to take a height and a width, and it's going to set self.grid equals, let's see, how exactly are we going to represent the grid? as trues and falses? Meh, let's just represent it as actual characters. That should be okay, right? But we'll represent it as a list of lists of characters rather than a list of strings. I think that sort of regularity will be a little more convenient. So what we're going to write is this times width. And I would like to write times height. But as I mentioned in a previous episode, this would give us like 15 copies of the same list rather than 15 different lists. So we can't do that, and we have to write for I in range, let's say, range of height. Give us height different arrays, lists, I should say, of this size. So that should be easy to test now, right? What is vars of grid of 5 by 3, let's say. That's interesting. Did I put too many brackets in somewhere? That doesn't seem quite right. Yes, there we go. Oh. Wait, so I want a list of characters. That makes a string. Why? I guess what I need is this. Take the list containing a character and multiply it by 8? Or by, not 8, by whatever. What does this do? Yeah, that's more what I wanted. I'm not totally sure. It feels to me like multiplying a list by a number should give you n copies of that list, rather than a list with n copies of the elements of that list. But, okay. There's probably a good reason why it is this way, and I'm not really inclined to think about it. So we'll just take it as a law of nature for now, I suppose. Okay, so now we can define a grid, and the thing that we want to do next is implement for each of these three methods, three objects. We're going to give them an apply method to make them give us a new grid, or make them change. We'll change the grid in place. It's the Python way. In Clojure, you would be inclined to make new grids that are changed, and in Haskell you would have no choice, of course, but to do it that way. But in Python, I think that changing the grid in place is a perfectly reasonable thing to do. And so before we start on that, actually, let's define a method called render here, that just for line in self.grid print nothing.join of line, right? Like that's all there is. This grid.render. Oh, whoops, call it, please. There we go. Sure, that seems fine. And so let's see. What's an easy thing to implement? Well, I think rect is pretty easy. Def apply self and g for grid to be for, let's see, how exactly is grid defined? Grid, the top left of the screen, wide by tall. Okay, got it. I was like, I only see two numbers, so I couldn't remember if they were width and height or like whatever. There's really only one plausible thing they could have been, but my brain was not working well enough to figure it out. So what we need to do is for y in rows for x in calls, and not rows, range of rows and range of calls, g dot grid of y of x equals hash. So let's try this. Would it be useful to return the grid at all? Whatever. We'll just write rect 1 and 2 calls and rows. This is actually a little bit inconsistent, isn't it? These things, this thing takes column then row, number of columns then number of rows, and grid takes number of rows then number of columns. So we should switch that. There we go. Rect of 1, 2 dot apply to g, or we called it g, right? No, we didn't even define it. Okay. So what we have to do then is first say g equals grid of 5, 3, and this time g.render, we get one that's wide rather than tall, which is sort of what I meant to have earlier. Rect 1, 2 should turn, oh shoot, how do I, there's a, I don't know, I forget how. There's some way in Emacs to, rather than selecting lines of text, to select a rectangle. I know I could put a space here and like, I could say xrk here, and it deletes those two characters that I nominally have selected, but I don't know how to make it display the selection as a rectangle. Anyway, so rect 1, 2 should set 1 column and 2 rows, so these two here, to be hashes. We did set it to hash, right? Yeah, okay. Rect of 1, 2 dot apply to g, please. Nope. Global name. Oh, self. It's a tradition to forget a self somewhere. All right, and we write g.render, and we did it. Okay, great. So that's the idea, is to define an apply method for each of these 3 things. And then iterate through all the lines in the input, applying that transformation to the grid. Now, you know what? I think that it's a little bit cleaner to do a little bit more work to do things a little bit differently. Rather than defining apply to mutate the grid, I'd like apply to return a list of coordinates and what to set them to. That's going to be a little bit less convenient for rect, but it will let us eliminate some duplication in row and column, where their job is to like iterate through to change the stuff in the grid, and it's going to be a little bit awkward to do a rotate because you're kind of copying over the data you want to read. And it's hard, like, if you shift a column to the right by 1, let's say, and you start with the leftmost column, then you'll copy, like, okay, where's my REPL here? Let's say we were trying to shift these two, this column we wanted to shift down. Well, what would be the most natural thing to do? Grab this. Actually, it's a little more interesting to talk about shifting this column right, this whole row right. Well, what's the most natural thing to do? Grab this and copy it here. Okay. But now when I try to grab this, there's a hash there. And I'll be, okay, let's copy that and put it here. And like, oh no, now there's a hash there too, right? So that's something that's going to be a little bit inconvenient if we make these apply methods modify the grid in place. Whereas if we have them first compute a series of changes that should be applied and then apply all of the changes, we won't have that problem. So let's not call it apply. Let's call it transform. And what it's going to return is a list, which is really just a tuple, I suppose, of y, x, hash for y in range of self.rows for x in range of self.calls. Am I missing a... Oh, whoops. There we go. So now let's try... And now, in fact, does it need a g? Yes, it does. We're going to ignore the g. So let's call it _g. I don't know if that's a thing you do in Python. I've seen it in other languages. This is just to indicate, yes, I'm intentionally ignoring this parameter. So let's now write... instead of apply, let's call transform of g has no... Did I not compile? Oh, invalid syntax. Why? Oh, there's an n. That happens sometimes. I'm using Control N to return. Always gotta forget returns and selfs. That's how you know you're writing Python. How you know I'm writing Python anyway. For y in range of self dot. I guess we should do this in the other order. I think it copied things a little bit inconveniently. Yeah, the 4 is on the wrong side. No, it's just, that's not the problem at all. The problem is that I really am used to using like a row major syntax where like y comes before... You know what, I'm not touching it. We're using a row major syntax here. Okay. So anyway, here's the list of transformations to apply. And now we need a single function distinct from row, call, and rect that, in fact, can live in grid, I suppose. Def apply self transformation, which is just for y, x, c for character in transformation self.grid of y of x equals c. So now we can say, let's define a new g again. G equals grid of 1, 3, g.render, and we should be back to an empty one. And now let's write g.apply the transformation produced by this, g.render. And we've achieved the same result, but without having rect be responsible for modifying anything in the grid, which A, is sort of like nice because immutability is cool. B, it, from like an object-oriented point of view, which they are not such big fans of immutability, you know, sometimes, but not all the time. But it's good from an object-oriented point of view too, because there's less coupling between the classes. Rect doesn't tinker with the internals, you might say, of grid. It does in that it goes through some row. Well, Rex doesn't go through the rows and columns of grid. It ignores it, right? Row and column will, but at least they won't modify it. So there's that. Anyway, so let's define these transform classes for row and column, and they should be reasonably simple now. Transform self G to be let's see, return for, no, not for. You got to put the 4 in the middle. I always want to put it at the front because, like, I'm writing a 4, but before I can say I'm writing a 4, I have to decide how to write it, and so like the wrong thing just pours out of my fingers. Return what? So we have a fixed row, and that's our y, right? So what we want is y to be constant, which is self.row. And then for each x, we're going to return g.grid of self.row of x. And we haven't defined x. That's coming up later in the for. Actually, x. Hang on. Here I want to write x plus amount mod g dot. Let's make the grid save its width and height. Why am I so far indented? Here we go. Self dot width equal width. What is wrong? Oh, it's because I'm in the middle of this for comprehension up here. Okay, that's why it's indenting funny, I think. No? Something else is wrong. Oh, this is still broken, that's why. Yeah, now it, okay. Self.width equals width, self.height equals height. And now g.grid, these were two separate expressions. X plus amount mod g dot width. X, yeah. Now we define what we're iterating over, which is 4x in range of g dot width, right? I think so. So let's just put the same thing into column, but instead we'll say, well, the thing that's constant here is say y, height, column y, and here we're putting self.column for y in range up to height. Does it compile at all? It does. Okay, well that's cool, I guess. So let's now try applying to G a row. What is the row? Takes which row and then the amount. So let's take row, yeah, 1 and 2. That's fine. So what I hope will happen is that this hash moves to the right into this location here, and everything else is dots. Okay, didn't work. That's fine. Oh, we need a new grid because we changed how grid works. That's fair. G equals, yes, okay. G.render, make sure we have the thing. We do. And now let's take a row. Okay. Global name, amount. Yeah, well, it needs to be self.amount. and the same in column. Where is it? All right, well, we're getting somewhere. Let's, instead of applying it, this makes more sense. G equals yes. And instead of applying it, let's just compute what the transform should be. So this is another reason that immutability is nice, is because you can, without having to inspect the state of your variables, you can see, hey, here's the computations my program is trying to run, and you can look at them as values and figure out what's going on. Okay. So the mod is like totally wrong. And of course it is, because I got the operator precedence wrong. I always feel like mod should bind more loosely than it does, and that's just my fault. There's no good reason it should do that. Yeah, this is better. So this has an assignment for everything on row 1 with well, so there's one problem here, which is that I forgot to flip these two index expressions. That's obviously not the problem, because we were actually working with a row expression, not a column expression. But notice that it has only, what's g.render? G.render. Oh, we forgot to. Okay, actually that's probably fine. It's probably totally right. We forgot that we have redefined g for whatever reason. G.apply rect of this. Now we have a g.render, and if we say row 1, 2 transform of g, it says, yep, you better put a hash at row 1, column 2. That's right here. So let's try g.apply of this transformation, g.render. Incredible. It worked. So what if we now tried to shift this this hash here down by a character? We would say, let's make a new column where the column number is 0 and the amount to shift by is 1, g.render, and it moved down. Okay, great. So we've got a handle on that. And we can now finish up our main pretty simply. We can just write g equals grid of, how big is the grid supposed to be? The screen is 50 pixels wide and 6 pixels tall. And we pass them in that order. So grid of 50 and 6. And we will write g.apply parse. Oh, we already have a call to parse in here. We have a parse thing here that gives us the operation, I guess you would call it. But before we can apply that, we need to compute its transform to apply to g. And we're going to actually apply that to g. And let's write g.render here. This won't give us the answer, but it'll display what the grid looks like. And I know from having peeked at the Reddit a little bit that that it's kind of that it looks cute. See, it's ASCII art. CFL Kfleloifx. All right. Oh wait, can you guys see all of that? Yeah, actually, for some reason, just by luck, it happens to be exactly as wide as the area that I have set aside for capture. Okay, well, great. So this doesn't quite answer the question that we had, which is how many pixels are lit up. but we can write print sum of 1 for y in g dot height for x in g dot width if g dot grid of y of x equals hash. Right? Int is not iterable. Yeah, that's true, but I didn't think I was trying to do that. Oh, we need a range. Range of g dot height, range of g dot width. How about now? 106. Okay. Let me find this window here. 106, please. It's correct. Amazing. Okay, how are we for time, and how complicated is part 2? Part 2. Oh, okay, good. You notice the screen is only capable of displaying capital letters. In the font it uses, each letter is 5 pixels wide and 6 tall. What code is the screen trying to display? Okay, so great. I thought that we might not... I certainly, like, if I hadn't looked around on Reddit a little bit, I wouldn't have... would not have discovered... Would not have guessed to try displaying the thing. I would have been just like, oh, here's the answer. So I'm glad that I wasn't, like, spoiled in some weird way, but rather this is something that the puzzle tells you to do. Also glad that it means, hey, we don't have any more work to do. So let's... And we implemented render just like for debugging, so, you know, okay. But let's, before we do part 2, let's git commit -m day 8? Yeah, of course, it's numbers right here. There's day 8, but it's easy to forget. Day 8, part 1. And we'll just also print g.render as well. No, we don't print that. That gets returned. Okay. And now run it again. And we see those day 8, part 2. And we get Kfleloifks. All right, I'm going to have to CFLE. Oh, are you guys? Yeah, okay. You're still. I thought I had forgotten to show you the running the code again. Kfleloiks. Let's see. Did I remember that well enough? CFLELOYFCS. Here we go. That's 10 characters. Submit. That's the right answer. Okay. Great. Well, as I mentioned to you, I have... Wait. Oh, right! Day 10 is out because it's not December 10th for me yet, but it is December 10th elsewhere. All right, well, whatever. We'll get to that later. I do feel up to at least trying to record one more episode. I don't know. Somebody suggested in the comments that if recording these lengthy programming sessions is too tiring, I should try just like implementing them myself off camera and then doing an on-camera walkthrough of the solution. That might be something that I give a try, but I'm going to try at least one more episode of interactive coding. Anyway, but if this episode is one that we are done with. Thanks for watching. Hope you enjoyed, and I will see you next time.